My name is Snehadip Kaur. I'm a sophomore at Wayne State University and I'm majoring in chemical engineering and pre-medicine. So in this video, I'm going to talk about how to use Bernoulli equation. You learn about this concept in Transport Phenomena 1. It is applied to fluid mechanics to study the movement of fluid over a shorter distance. So as you can see, a Bernoulli equation, there are two of them that I wrote down. They're both the same, but it's just arranged differently. If we look at the first one, it is 1/2 rho v1 squared plus rho gh1 plus p1 equals 1/2 rho v2 squared plus rho gh2 plus p2. So all these symbols, rho is for density, and v is for velocity, g is for gravity, h is for height, and p is for pressure. And another way to write this, like if the second equation is just having the top equation on one side and have it set equal to 0. So that comes out to be 1/2 bracket v2 squared minus v1 squared bracket plus p2 minus p1 divided by rho plus g h2 minus h1 equals 0. So I'll be doing a couple of problems that would use both equations so you guys can see that they're both the same. There aren't that many differences between them. I'm just going to zoom out here. Okay. Let's make this a little bigger. So as you can see, the first problem, I wrote down the first equation that we will be using here. So right now we're using this part right here as our point 1 and this as point 2. We are trying to find the velocity, which is v2 right here. v2 equals v. They're the same thing. So if you look at the equation, I used 1/2 rho vt squared instead of writing v1 squared because they're the same thing. I picked t because it says t right here. Then it says p naught here, so I picked p naught. And then plus rho g h t plus pt equals 1/2 rho v naught squared plus rho gh naught plus p naught. So first things first. First of all, we have to see what is the information that is already given to us. So let's see. So we can see that there's density right here, which is density of water. So we know that we have that right here. So we have density that is 1000 or 10 to the cube, doesn't matter, kilograms per cubic meter. So this means right here in the container is all water. And then we know what PT is, our pressure. So PT equals 3 times 10 to the 5 pascals. We have P naught, which equals 10 to the 5 pascal. And then what else do we have? Let's see. So we also have the height that's given right here. Delta H equals 0.25 meters. And then we're trying to find V2, which equals V naught, which is the same thing as V in this case. But I'm going to be using V naught. We're trying to find that, meters per second. And let's see what our VT is, which is V1. So right here, so we know that this is water in the container, and this water is not moving. So this is stationary. So if something is stationary, it does not have any velocity. So Vt is 0 meters per second. And make sure all the units are staying the same. So we'll always be using pascals for pressure and meters for height, and meters per second for velocity, and kilograms per cubic meters for density. So now we have all the information. Let's try plugging everything in our equation. So first thing, 1/2. So that's his rho. Well, I'm not gonna plug in the value for rho here. And then it says Vt squared. What is our Vt? That's 0 meters per second. So that would be 0 squared plus, I'm gonna write everything same. I'm just gonna copy it down. Rho g ht plus pt equals 1/2 rho v naught squared plus rho g h naught plus p naught. So we know that this first term cancels out to be 0. Then I'm going to subtract p naught from both sides, minus p naught. And then I'm going to subtract rho g ht from both sides, rho g ht minus rho g ht. So I'm using purple to cancel out the terms. So this cancels out, and then this cancels out. So now we are left with pt minus p naught equals 1/2 rho v naught squared plus rho g h naught minus rho g h t. We can take rho g, we can take rho g as common factor here, which gives us pt minus p naught equals 1/2 rho v naught squared plus rho g h naught minus ht. So this is h naught, and if this is our ht, h naught minus ht is another way of saying delta h. So I'm just gonna say that this is delta h. Now let's plug in all the values that we have. Pt, that is 3 times 10 to the 5 minus 10 to the 5, which is p naught, equals 1/2. We already have the density, which is 1000. We are trying to find v naught squared plus density 1000, gravity 9.8, delta H is 0.25. Once you solve the left-hand side, you get 200,000 equal 500 v naught squared plus, let's put that in our calculator and see what we get. 1000 times 9.8 times 0.25, which gives 2,450. Now I'm going to subtract 2,450 from both sides. I'm going to use purple to cross it out. So this goes away. And then on the left-hand side, we are left with 197,550 equal 500 V naught squared. Divide both sides by 500. You get 395.1 equals V naught squared. Then you take the square root, and the answer is 390. I'm sorry. And the answer is 19.88 meters per second. So that will be the final answer. So just to look at the problem as a whole, first we have our equation, then you decide which is going to be your 1 and 2. So I picked 1 right here and 2 over there. And then let's see, we look for what's the information that's already given so that we can try and see how to put everything in the equation. So we list all the information that is given, and then you plug it in the equation and try to cancel everything out that you can, and then you get your final answer. Okay, we can try doing some more problems and let's see how that goes. Problem 2. I'm going to use the same equation that I used last time here, which is 1/2 rho v squared plus rho g h plus p naught equal 1/2 rho u squared plus rho gh plus pa plus pa. So you're probably wondering, why did I not write 1 and 2s? So I'll mention that in just a second. I'm gonna make this picture a little bigger. Okay. So in this case, my 1 is right here, and this is my 2. So for v squared, since it says v, so I just put v because it's just easy to see what's in the picture and then use it rather than having 1s and 2s, which can confuse you. But you can do whatever works for you. Then there's u right here, which is v2. And then I didn't put anything for the heights. Why? Because they're the same. That there is no difference in the height. It's still going this way at the same level. And then we are trying to find the difference in pressures here. So let's do this. Let's see what's the information that we're already given. So we have velocity, that's 10 meters per second. For v, we have u, which is going at 4 meters per second. Then we have density. What does this density tell us? That this is water. The liquid that's flowing is water. And we are trying to find PA minus P naught. So we already given all the information, so let's see what we get. So we know that since rho GH and rho GH are the same on both sides, it's just gonna cancel out. There's no difference in the heights. First we cancel that out, and now let's plug in all the values. 1/2 times 1000. What is V? Which is 10 squared plus P naught equal 1/2 1000. And then U is 4 meters per second squared plus PA. So on the left hand side you get 50,000 plus P naught equal 8,000 plus PA. Subtract 8,000 from both ends. And then I'm going to subtract P naught from both ends, because it says right here it wants PA minus P naught. On the left hand side, I'll get 42,000 equals PA minus P naught. Doesn't matter which way you write, I will always write in the standard form. PA minus P naught equal 42,000 Pascal. So that is your answer for this part. I'll just put a side note so that we know that why did the rho GH cancel out? Because H, which is height, stays the same. Okay, so again we do the same thing. First you see what you write down the equation, then you look at what is already given, and then you plug in all the values to find what you're looking for. Now let's try the third problem. For this problem, I am going to use the second equation that I mentioned in the beginning. So I'll be using this one now. I'm going to make this more bigger. It's more visible. Okay. So first I'm going to write the equation. This problem is way different because it also has a manometer. So we would have to account for that too. Let's first write our equation. 1/2 V2 squared minus V1 squared plus P2 minus P1 over rho plus G times H2 minus H1 equal 0. So this is our basic Bernoulli equation. So now let's see. So this is our point 1. That's the first thing you always do. This is our point 2. We are trying to find V2 here. But we have to make sure that we are accounting for this bottom system. So in this part, we have two systems. Top and then bottom. And like when I'm talking about one, I'm talking about the point right here. So let's see what are we given. We already have height, we have a density. So we do know that this is not water. The liquid that's flowing in here is not water. But we know that this is water. So the density right here is going to be 1,000 kilogram per cubic meter. So first, we know that we need to find P1, right, which is the pressure right here. So we need to find P1 first, and then for P2, we know that the tube is open right at this end. So P2, at this end, the tube is open, so atmospheric pressure is acting. So we are gonna say that our P2 is 1 atm, but since we need pascals, it is going to be 101,300 Pascal. So now we already have our P1 value. I'm sorry, P2 value. Now we need to find P1. For the P1 portion, we need to make sure that we count the effect of the manometer portion right here. So how do we do that? So that is P1 equals P ATM, which is atmospheric pressure, plus rho GH. Here, I'm going to underline the rho with red so that we know that we're talking about this rho right here. So we already know what's the atmospheric, 101,300, because we want to find it in pascals, plus density, which is 1,000, gravity, that is negative 9.8, and then for our height, we'll be using 50, but since it's in millimeters, you're going to convert it. How do we do conversion from millimeters to meters? So 1 meter has 1,000 millimeters. And then millimeters cancel out, you're left with meters. So let's see what we get in the calculator. $1,000 times 9.8 times 50 over 1,000. That gives us negative 490, which means our P1 is 100,810 Pascal. Now we also have our P1, which is 100,810 Pascals. So now you must be wondering how to find velocities here, because the fluid is not stationary anywhere, it's moving. This entire time it's flowing. So for that, we look at flow rate. There is another equation that I'm going to add. It's about flow rate. It's Q equals V1 A1 equals V2 A2. Flow rate stays the same at both points because there is no change in height or anything. So from this equation, we can say that V1 equals V2 A2 over A1. So in order to find areas, we need so since this is a tube, formula for area is going to be A2 equals pi R2 squared. A1 equals pi R1 squared. So now, let's see what our R's are. So as we said in the picture right here, that this is our point 1. So this part right here is our diameter 1, and this is diameter 2. So I'm going to write it underneath here. Diameter 1 equals 50 millimeters, which means that R1 would be 25 millimeters. But again, we know that our units has to be in meters. 1 meter is 1,000 millimeters, which gives you 0.025 meters. Now let's do the R2. So here, we know it's 100 millimeters, which means R2 is 100 over 2, 50 millimeters, 1 meter is 1000 millimeters, and R2 equals 0.050 meters. Millimeters cancel out. So now we have all the values that we can use. Let's write down our Bernoulli equation. That is 1/2 V2 squared minus V1 squared plus P2 minus P1 over rho plus G H2 minus H1 equals 0. So in this case, our height is 0 because the tube is straight. There isn't, manometer does not count. Right now we are talking about the top system. So let's plug in what we have. 1/2 V2 squared minus, so we knew that V1 is V2 A2 over A1 squared. Do not forget to square it. Plus P2 minus P1. P2 was 101,300 minus 100,810. And our density, this is the density that's for the fluid in the tube. So that's the density that we will be using, 1.2. So 1.2 plus 0 equals 0. This leaves us with 1/2 V2 squared minus V2 squared pi R2 squared. Make sure you're squaring it because it's A2 squared pi R1 squared plus, solve that in calculator, you get 1,225 over 3 equals 0. Missing a bracket here. Here we go. Then it's 1/2 V2 squared minus V2 squared pi, our R1, R2 is 0.05 square pi 0.025, it is our R1 value, square plus 1,225 over 3. And then we get 1/2 V2 squared minus 6.169 times 10 to the negative 5 V2 squared over 3.855 times 10 to the negative 6. I'm going to subtract 1,225 over 3 from both sides. That gives you negative 1,225 by 3. And then I'm going to multiply 2 by both sides. So you're left with, we're going to take the least common denominator for this. That gives you your least common denominator as 3.855 times 10 to the negative 6. So since there's a 1, so if you multiply that by denominator by 3.855 times 10 to the negative 6, you multiply the numerator by the same thing, which gives you 3.855 times 10 to the negative 6 V2 squared minus 6.169 times 10 to the negative 5 v2 squared equal negative 2450 over 3. So after solving the fraction on the left hand side, we get 5.8. I'm sorry, 5.7875 times 10 to the negative 5 divided by 3.855 times 10 to the negative 6 v2 squared. So there's a negative in front of it. Negative 2450 over 3. And then these negatives cancel out because they're on both sides. You get, let's put that in the calculator. Let's put our fraction in the calculator and see what we get. 5.7875 times 10 to the negative 5 divided by 3.855 times 10 to the negative 6. And I get so in the fraction I'm gonna zoom out a little bit so that you can see the steps above it. 11575 over 771 v2 squared equals 2450 over 3. From here, I'm going to solve this. v2 squared equals 2450 over 3 times 771 over 11575, which gives me v2 squared equals 54.397, which means v2 equals 7.38 meters per second. So that's your answer. So there are a lot of different ways to do these problems. We learned the two basic equations, which are just rearranged. And then the two new things that we learned is that the flow rate, that stays the same. So it's V1A1 equals V2A2. And then another thing, how to solve manometer problems. And again, this was the bottom system. I hope these problems will help you when you are going to work on it. Thank you, and I hope you have a great day.